So we've got sector, which is OAB. I remember sector because it's got a C in it, which then goes for centre. It's also got an O in it, and we normally label the centre of the circle O. Anyhow, that's what we've got. Angle radians, set my calculator to radians, find the exact length, so it means I will be using a calculator, but I must be exact about this, and I've got an arc length, and I know the formula for the arc length is r theta when theta is measured in radians. So that'll be r, which is 12, times by 2/3 pi, and 3 cancels out with 12 to give 4, and that'll give me 8 pi, and it was in centimetres. So that's the exact. Part 2, the exact area of the shaded segment. So the segment area equals the area of the whole sector, I'll put the formula in just a second, minus the area of triangle, and that is a half r squared theta when theta is in radians, and that is a half of two sides times together times by sine of the angle between them. This is half r squared, it's 12 squared, I'm going to put down 12 times 12, times by the angle, so that's times by 2 pi over 3, and then I've got to take away half of two sides times together, so that's 12, and I've got this one here, which is 12, so I'm going to put 12 times 12, times by sine of the angle between them, which is 2 pi over 3. Your calculator will probably say it, but if I've got an angle, I'm going to use a unit circle, and that's a sine axis. I want 2 pi. 2 pi is 360, divided by 3 is 120 degrees. 120 degrees would be around about up here. And so this bit will be 30 here, and so this bit to there, it's obviously not a half, it's going to be root 3 over 2. And so this will give me 2 and 12 cancel to give 6, 12 and 3 will cancel out to give 4 and 1, that's 24, that's 48 pi, minus that bit at the end there is root 3 over 2, so the half will cancel out with that to give 6, the 2 will cancel out with that to give another 6, and we've got 36, so that would be 36 root 3. I can't, well, I could take out, I suppose, a factor of 12 if I wanted to, but that will do me. You could spend longer doing that, or your calculator will probably do it for you. That you don't need this bit. You actually don't need to be working in radians, because you could have just said, if you had that in degrees, you could have said you had that angle out of 360, and that'd be your proportion of the whole circle. And the whole, if it's a area, then we'd be using pi r squared, and if it's a diameter, if it's a circumference, we'd be using 2 pi r or pi d. So we could have used those, but anyhow, that is question 3 done.